All right, welcome back. Crunching through this stuff. So, in our most recent video, we figured out combined gas law is the exact same as what you were doing yesterday. We added pressure. So the only thing that we changed was we added the variable pressure. We figured out how to convert pressure units. These are units you want pressure in kPa, kilopascals, 101 kilopascals in 1 atmosphere. You can use that conversion factor every single time. This may be helpful for you. If you so desire to use this page, go for it anytime. This is that combined gas law solved for any variable. Alright, let's go. If you've got your packet, you're looking at this page. Combined gas law is 67. Wow, we're just like charging through. That's good. Off we go. Okay, so this first one here, let's look at this. We initially have 4 liters of gas, so like 2 2-liter bottles, at a pressure of 1.1 atmosphere, so like a little bit more than normal atmosphere. What will be the volume if I increase the pressure? Okay, so we're like squishing it a lot. We're increasing the pressure to 3.4 atmospheres. Okay, here we go. And actually, before I even, you probably have noticed there's the absence of something here. We have some volume, we have some pressure. What are we missing information on? Temperature. Nothing mentioned temperature. If nothing mentions a variable at all, or something does not at all mention a variable, you're going to assume it stays constant the whole time. Let's look at what that means. Okay, so we are changing conditions. This is question 1. We are changing start to end. So initial, we have a volume of 4 liters at a pressure of 1.1 atmospheres. I'm gonna give myself a little bit more space because I'm like, hey now, we're in atmospheres, we want kPa. Unlike that other thing where I just converted right on to the other side, I'm gonna give myself some space. What will be the volume? Volume is question mark. If I increase the pressure, so the end state is the increased pressure of 3.4 atmospheres. Yeah, you're thinking to yourself, I'm so used to temperature, it doesn't say anything about temperature. We are going to assume that the temperature is the same. And since in your equation, I should have showed you this in your equation has T1 and T2 on different sides of the fraction. It's something divided by itself. Whatever it is, because it is implied constant, you can get rid of it. The rest of this we cannot get rid of. You're going to take your atmospheres to kPa. We went over in the last video how to convert from atmospheres to kPa. It's 101. Try again. 1 atmosphere is 101 kPa. And every year I get good at multiplying by 101 again. I think this is going to be, well, let's just do it. 1.1 times 101. Yeah. Oh, 111. So it's a little bit, okay, whatever. So it's 111 kPa is our starting pressure. Do the same thing over here. I'm going to convert these atmospheres to kPa. I'll do this one a little bit bigger over here. 1 atmosphere is 101 kPa. 3.4 times 101. 343.4 kPa. We got our question translated, got our units. We want volume in liters, got that. We want pressure in kPa. We did those 2 conversions, we got that. On to step 2. Step 2 We're in this combined gas law realm. We have pressure now also. We're solving for the end volume, V2, the end volume. I'm happy to walk you through the algebra, but for right now, let's just pull an equation from here. So we want the end volume. We're solving for V2. You're copying that equation, onto your page. You're going to see some patterns. P1, V1 over T1. Actually, maybe that's not a pattern yet. That'll become a pattern, don't worry. Times T2 over P2. Again, let me know if you want to see more. If you want to see more algebra, let me know anytime. Okay, so we're solving for, I like algebra. I like math. So V2 is P1, V1 over T1 times, so here's what we did to take that original equation into this kind of solved form, times T2 over P2. Plug in your numbers. Starting pressure, kPa. Starting volume in liters. Ending temperature wasn't mentioned. We're going to assume the ending temperature was the same as the starting temperature, and it's gone. We don't have to worry about it. That P2 is still here though. Your ending pressure is your 343.4 kPa. And because you did all that work with your setup, by the time you got to your equation, you just plugged in numbers. And we're just gonna math those numbers. 111.1 times 4, those are the things on top, divided by 343.4. Should make a prediction before we do our math. We started with a big volume at a normal pressure, and then we squished the crap out of this thing. We took this underwater, or sat on it, or squished it as much as we could possibly squish it. And you would predict, since you're squishing it, you're taking your thing and you're like, feel whatever. You're going to predict, since you squished it, your volume's going to decrease. And that's a great thing to do before you actually do your math, so that you can check yourself and see if your math makes any darn sense at all. And in this case, it does. That's what our calculator says. You need units on every single number. You have kPa on top and bottom. Those are units. We just canceled out units. Liters is the unit left on top. Your ending volume is a much smaller amount of liters. That makes sense. Okay. I want you to do 3 practice again, but I also want to give you an example that actually has all 3 variables in it. Okay. So... so I'm going to do number 2 with you, just to get you an example with temperature also. And then you're going to do 3 questions for practice. Okay. I'll just put this at the top of this page so you can see it. Here's question number 2. These all have 3 steps, so you're getting used to that. Toy balloon, let's just make sure this has all 3 variables, shall we? Toy balloon has an internal pressure of 1.05 atmospheres, so that makes sense, and a volume of 5 liters. That's a big toy balloon. If the temperature were, okay, we have all 3. We have pressure, volume, and temperature. If the temperature where the balloon is released is 25 degrees Celsius, room temperature, what will happen to the volume? So we're going to solve for volume. When the balloon rises to an altitude, we just let this balloon into the sky, where the pressure is 0.65 atmosphere, and the temperature is negative 15 Celsius. We're going to see some changes here. So we're decreasing the pressure. Unlike this top one where you squished it, now you're releasing the pressure. Now this is up in the atmosphere, there's less pressure. And the temperature is really cold, negative 15 Celsius. Okay, this has all 3 variables. It has a start condition and an end condition. So we're going to say the start is on the surface of Earth, the end is up in the sky. Off we go. We have a pressure, a volume, and a temperature. This is why we're doing this one together. Because eventually, I mean, you're given 5 numbers here, and you're solving for a 6th. Off we go. You can do it. You got this. No worries. Toy balloon has an internal pressure of 1.05. I should be doing these in color. There's a chance that this will be a click moment for, because now you have 3 types of variables. So we have a pressure of 1.05 atmospheres. That's your starting pressure. And a volume. And we'll work with those units as well. Volume of 5 liters. That's your volume. And a temperature, where it's released, 25 degrees Celsius. What will happen to the volume? Let's fill those in. So your starting volume is 5 liters. And your starting temperature is 25 degrees Celsius. What will happen to the volume? So liters is volume, that's our volume stuff. What will happen to the volume equals question mark. Oops, question mark. When the balloon rises to an altitude where the pressure is 0.65 atmospheres. And the temperature is negative 15 Celsius. Ooh. Feel free to color code these. It's sometimes helpful to put, just because there's 5 numbers here, so if we keep our pressure the same color, our volume the same color, and our temperature the same color, that can help to kind of organize it a little bit. Half your challenge is reading your question and keeping track of your start conditions, so on the surface, versus your end conditions, in this case in the sky. Translator question. Next up is the units. We want volume in liters. Yay! Let's do temperature next. That's the one you're most familiar with. We want temperature in Kelvin, so plus 273. Plus 273, here's another negative. You could do 273 minus 15. 258, I think. I'm going to do this on my calculator just so that I don't mess anybody up here. So 273, and I'm going to do 273 minus 15 is what I'm going to do. Okay, great. That's your temperature in Kelvin. And your pressure in atmosphere. 101 kPa, 1 atmosphere. If you're looking at this and you're like, dude, we don't actually need to convert, I don't want to say that out loud. For the most part, I want you converting. And there's a really specific reason that you're going to find out tomorrow. Write me a note in that list of things that you know if you are seeing an error. Otherwise, everyone is converting. So you're taking your atmospheres to kPa. 1 atmosphere is 101 kPa. Do the same thing again over here. 1 atmosphere, 101 kPa. 0.65. No, yeah, 0.65 times 101. 65.65 kPa. That's your step one. That's your setup step. Do you need to write this every time? Yes, you do. This is worth as much as anything else. Truly, like point-wise. Like, I should articulate that. Your setup is worth a full third to half of every question because it has these two really important components in it, like figuring out what the question means, reading this word question, and converting your units. Okay, so there's your setup step. I'll add that in for you. Your second step is your equation. You're solving for the ending volume. Solving for the ending volume. Feel free to pause the video if you wanted to see that longer. P1 V1 over T1 times T2 over P2. Your setup is now ready to go. Starting pressure, 6.05 kPa. Starting volume, 5 liters. Ending temperature, up in the atmosphere, 258 Kelvin. Starting temperature, 298 Kelvin. I sometimes line these up so that my units are really obvious and can cancel really easily, and then I'm like really clear on what I'm solving for. There's your starting temperature, your ending pressure, 65.65 kPa. Okay. You found which equation you're using. You're solving for V2, your ending volume, so we pulled that equation from your page. This is your general equation. Do write this. This will help you. Because when you go to plug things in, it's easy to get this confused. But if you have your general equation written right here, you will be much closer to 100% confident and correct every time. Right, so there's your P1, there's your V1, there's your T2, there's your T1, there's your P2. That went way too fast. Rewind, look at your setup. I just pulled those numbers right from your setup. So your ones are your start condition, your start pressure, start volume, start temperature. Your twos are your end condition, end temperature, end pressure. In your final adventure, plug that into your calculator. So we've got 106.05 times 5 times 258. Those are all the things on top, equals, divide, 65.65 equals, divide 298. And we probably should have made a prediction about what was going to happen, although this had the interesting attribute that the temperature decreased, so you'd expect it to shrink, but the pressure also decreased, so you'd expect it to expand. This is an example of a question where I would not be giving a really great prediction. I mean, you can kind of look at the numbers and guess, but you don't know, because you had something that leaned towards expanding and something that leaned towards compression. And this is what your calculator says. Thanks, calculator. Find your unit. You get temperature on top and the bottom, Kelvins cancel, kPa on the top and the bottom, pressure cancels. You are left with the unit of liter. That is the unit that you just solved for. Your volume is in liters. That's good. That's another check you want to do. And in this case, your balloon expanded, which is what we would expect having released it into the atmosphere. All right. Whew. Okay, so for homework, you are trying 3 more questions. You're trying 3 and 4, and I will post the other one based on what I read on the back. I'm not going to make you wait for me to read it. But definitely 3 and 4. Go ahead and get started on those, and I'll tell you which one you're doing on the back as well. Okay. Yeah, see you soon. Adios.